Mhm. So good evening. In this session, we'll solve from question number 40. Let's go ahead. So you have a continuous function defined from 0 to 2 to r and satisfying this thing. Then the value of cot inverse of this thing. That means all we need is the function from here, and then we just have to plug in everything here. So let's go ahead. So I have integral 0 to 2 f of x into x minus f of x dx. This is given to be 2 over 3, which means now we can write down 0 to 2 and then I'll multiply here. So I'll be having x into f of x minus f of x square dx. This is f of x square is equal to 2 over 3. This thing we can further write down integral 0 to 2 f of x square minus x into f of x dx is equal to minus 2 over 3. Now, the ideal thought would be here nothing is given to us. So that means we need to extract this function from this definite integration. And we cannot use neutral limits because here this is 0 to 2. So that means we now need to find out the official function f of x by using some condition. Let's see what do we get. So f of x is square minus x into f of x I'll take, and then 0 to 2, and this is going to be f of x square minus x times f of x plus x square. This is kind of quadratic equation, so I can think of adjusting the constant term. That means this is f of x square minus f of x. So this is quadratic in f of x. That means I have to adjust here x square over 4, and I'll subtract x square over 4 dx, and this is minus 2 over 3. Now let's go ahead. So integral 0 to 2, and this guy is simply f of x minus x over 2 the whole square, and then minus of integral 0 to 2 x square over 4 dx. This is minus 2 over 3. Now I'll evaluate this thing. So integral 0 to 2 f of x minus x over 2 square, and then minus this 1 over 4 will be here as it is, 1 over 3 would be there, and then 2 cube. Now this is equal to minus 2 over 3. And now this is 8 over 8. So I can cancel 4 and 2 here. So I get minus 2 over 3, and this minus 2 over 3 gets cancelled. That means I get integral 0 to 2 f of x minus x over 2 the whole square dx is equal to 0. So now we can use the result. Okay, so integral a to b f square dx is equal to 0. This implies f itself is 0. So if f is continuous in AB. So if f is continuous in AB, that's the condition. So I should have written the same way, that if f is continuous function and integral a to b f square dx is 0, that means my function must be 0, because we are saying the positive part of the function is 0. And function f is continuous in a to b, which means f identically should be 0. Otherwise, this thing is not possible. So that means from here, I can say that f of x is simply x over 2. So we found f of x is equal to x over 2. Now the next part is n is equal to 0 to infinity. So, sigma n is equal to 0 to infinity. And then this turns out to be cot inverse of 1 plus 4 times f of n. So cot inverse of 1 plus 4 times f of n into f of n plus 1. This can be written as sigma n is equal to 0 to infinity cot inverse. I'll write down here tan inverse, and then 1 over, this is 1 plus 4 into f of n is n over 2 into n over 2. This is n plus 1, of course. This part we have now, this turns out to be telescoping. So n is equal to 0 to infinity tan inverse of, this is 1 over this 4 gets cancelled. So I get here n into n plus 1. Now this further can be written as n is equal to 0 to infinity tan inverse of, this one would be n plus 1 minus n over 1 plus n into n plus 1. And this reminds me of, wait a moment. So if you recall, tan inverse of x minus y over, this is 1 plus x into y. So we are solving for the principal value branch, of course. That means this is going to be tan inverse of x minus tan inverse of y. So this could be further written as sigma n is equal to 0 to infinity tan inverse of, so it's going to be n plus 1 minus tan inverse of n. Now, since this is infinite limit, so what we will do is we'll write down here limit n tends to infinity sigma k is equal to 0 to n, that tan inverse of k plus 1 minus tan inverse of k, which means now if I apply the telescoping sum, I'll be having here limit n tends to infinity. This is going to be tan inverse of n plus 1 and minus tan inverse of 0, the telescoping part. And then this guy will become 0, and this guy, and n tends to infinity, so tan inverse of infinity will turn out to be pi over 2. So the final answer here would be pi over. We have the next question, number 41. Let's go ahead. So we are given that modulus of z2 plus I z1 is equal to modulus z1 plus modulus z2. Now, this condition, we'll have to extract some information. Meanwhile, mod z1 is given to be 3, mod z2 is 4. Then area of the triangle ABC, if fx's of ABC are, okay. So this is for A, this is for B, and this one is for C. All right. So let's see what is the relation between Z1 and Z2 from here. So mod of Z2 plus I Z1 is equal to mod of Z1 plus Z2. So you recall Z1 plus Z2 is equal to mod of Z1 plus mod of Z2. So this implies Z1, 0, Z2 are collinear. Or one can say that argument of Z1 is equal to argument of Z2. So we can apply the same concept here because their moduli are equal. So the triangle inequality has turned out to be equality, which means argument of Z2 is equal to argument of I Z1. So that means argument of Z2 is equal to argument of I plus argument of Z1. Now, argument of I is going to be pi by 2 and plus argument of Z1. And here we have argument of Z2. We can transfer this one here. So I'll be having argument of Z2 minus argument of Z1 is equal to pi over 2. Now this could be further written as argument of Z2 over Z1 is equal to pi over 2. So we want to see this thing. So I want to include one more coordinate into the picture. That means I can write down argument of Z2 minus 0 over Z1 minus 0 is equal to pi over 2. So this looks like an arc, basically. So argument of Z2 minus 0 over Z2 minus Z1 is nothing but pi by 2. That means if I take this, what? Same thing again. Okay. So try to remove the slide itself. So now we have, it will be somewhat like this. So we are saying that if I rotate Z1 anti-clockwise by pi by 2, it becomes Z2. That's meaning. So suppose my Z1 is here somewhere, and if I rotate it pi by 2 anti-clockwise, so I get my Z2. So it is somewhat like this. We can think of. So this is my Z2. So these two are perpendicular. So I can get a triangle here like this. Now let's go ahead. So this is Z1, this is Z2, and then there is one more triangle, that's Z3, and this turns out to be this one. So I can write down Z3 is equal to Z2 minus I Z1 over 1 minus I. So I can write down now Z3 minus Z3I is equal to Z2 minus I Z1. So let's check this one here. So I'll be having Z3 minus Z2 is equal to Z3 minus Z1 into I. And now this could be written as Z3 minus Z2 over Z3 minus Z1 is equal to I. That means this number is purely imaginary. So this implies I can say that argument of Z3 minus Z2 over Z3 minus Z1 is pi by 2. And also from here, I see that if I take the modulus on both sides, so I know that mod of Z3 minus Z2 is equal to mod of Z3 minus Z1. So that means Z3 minus Z1 if I rotate, okay, Z3 minus Z1 if I rotate anti-clockwise by pi by 2 to get Z3 minus Z2. So that means I can write down one more triangle here, okay, like this. So there's here somewhere is my Z3. So we are saying that Z3 minus Z1 when rotated by pi by 2, okay, anti-clockwise. So that means this is my Z1 minus Z3. I'm rotating this anti-clockwise 90 degrees. So I get Z3 minus Z2. And since these two moduli are same, so say this is A right here, and this one is B, and this one is C. So now we need the area of this triangle ABC basically. So we need the blue shaded area right down here. This one I need. So this area I need. So that means we'll now find out first this side. So of base into height we can apply. All right. So we have this thing at least. So mod of Z1 is what? 3, and mod of Z2 is given to be 4, which means mod of this one Z1 minus Z2 is going to be 5 here. So now we can apply Pythagoras theorem, and since we know that these two moduli are equal, so that means it is isosceles right angled triangle. So I can apply here AC square plus BC square is equal to 5 square, and since AC is equal to BC, so 2 times AC square is equal to 25. So AC is going to be 5 over root 2. So this is AC now. So we have AC here. Yeah, that's AC is 5 root 2. So if AC is 5 root 2, then BC is also 5 root 2. So this implies BC is also 5 over root 2. So AC and BC both are equal. And also, I want the area of this triangle. So area of the triangle is going to be what? Half into base into height we can do. So base is 5 over root 2 and same is the height. So this turns out to be 25 over 4. So the answer would be 25 over 4. Let's go to the next question. So here is another one. So electronic component manufactured by a company is tested for its defectiveness by a device. Let A denote the event that the device is defective. So we'll write down like this. Device is defective. And B denote the event the testing device reveals the component to be defective. So we'll write the testing device reveals. Testing device reveals the component to be defective. It's the component to be defective. And now we are given that P of A is alpha. So P of A is given to be alpha, and P of B given A, P of B dash B complement given A complement is 1 minus A. If it is given that the testing device reveals to be defective, then the probability that the component is not defective. So we want probability of component is not defective. Here it's given to be what? Device is defective. That means we want the device to be not defective. That means we need to find out A complement given that testing device reveals the component to be defective. That means it is given to B. So we want this thing. So if it is given, this is conditional probability. That means we'll go ahead with the conditional definition. So A complement be given B is going to be a probability of A complement intersection B over probability of B. So A complement intersection B is probability of B minus probability of A intersection B. This over P of B. Now I can split this to have 1 minus P of A intersection B over P of B. I'll call this equation star. So we now need to find out P of A intersection B and P of B. And we have none of them. So let's go ahead. Also, we are given that P of B given A. So P of B given A is 1 minus alpha and P of this B complement over A complement. So P of B complement over A complement is given to be again 1 minus alpha. So we can open this thing. So let's find P of B given A. So P of B given A is going to be P of A intersection B over P of A is equal to 1 minus alpha. And if I open this thing, so I get here P of A complement intersection B complement over P of A complement. Now this could be written as P of A union B the whole complement over 1 minus P of A. P of A union B is nothing but 1 minus P of A union B and then 1 minus P of A. So we can expand this further and write down P of A plus P of B minus P of A intersection B on 1 minus P of A. So this is given to be 1 minus alpha here. And 1 minus alpha will now be equal to 1 minus P of A is given to be alpha, yes. It's given here, alpha. So P of A is what? Alpha plus P of B, we don't know. And P of A intersection B also we don't know. So let's write it the same way, P of A intersection B. And this is 1 minus P of A, so it is alpha. Let's keep this in here. So this will give me 1 minus alpha, the whole square is equal to 1 minus alpha minus P of B, and then plus P of A intersection B. That's what we have. Now let us see what do we have. So, okay, that means from here, P of A intersection B we can write down. So I have 1 minus alpha square is equal to 1 minus alpha minus P of B, and then P of A intersection B I can write down plus 1 minus alpha into P of A, which is alpha. So now open this. So 1 minus 2 alpha plus alpha square is equal to 1 minus alpha minus P of B, then plus alpha minus alpha square. So this plus alpha and minus alpha, this gets cancelled. This 1 and 1 gets cancelled. I can transfer this one to this side to give me P of B is equal to 2 alpha minus 2 alpha square. So this could be written as P of B is equal to 2 alpha into 1 minus alpha. This is my P of B. So we have found P of B. Once P of B is obtained, now we'll just go here. So we need P of intersection B. So let's write down P of intersection B is basically from here. P of intersection B can be written as 1 minus alpha into P of A. So that means I have here 1 minus alpha into alpha upon P of B we have found to be 2 times alpha into 1 minus alpha. So 2 times alpha into 1 minus alpha. Now since alpha is non-zero, I can get them cancelled, and this is 1 minus half, which happens to be half. So the probability is going to be 1 by 2. Let's go for the next problem. The next one, we want the value of this 3 to the power 10. 3 to the power 10, 20C10 into 20C0 minus 3 to the power 9, and then again 20C1. 19C9 into 20C1 and so on up to this is 10C0 into 20C10. So we want the value of this thing. So of course, if I just look at this power 3 to the power 10, here also we have 10, and this 9, 20, no, wait, 3 power 0 we can write here. So 3 power 0 and here 10C0. That means these two are basically related. This is not related, 10C0. Power 10, 20C10. Okay, so this is 20C10 and then 10C0, 19T9. Okay, so it should be just 10C0 only. All right. So 20C10, I'll keep it here. Now, if I just look at these two, so I can now write down this is nothing but the coefficient of x to the power 10 in. So if I just look at this coefficient of x to the power 10, so this is 20c10 into 3 to the power 10, which clearly indicates that this is nothing but the expansion of x plus 3 or 3 plus x. So we can write on any form. This is going to be 3 plus x to the power 20. 3 plus x to the power 20, I can write on here. Because if I write on the expansion here, this is going to be 20 cr, and then 3 to the power 20 minus r, and then x to the power r. So x power 10. And then similarly, I can now write down this one as what? Coefficient of, let's go ahead and see here. So this is nothing wrong. All these things here. So coefficient of x to the power 10 in 3 plus x to the power 20. And this is nothing but coefficient of x to the power 10 in 3 plus x power 19. So 19 minus 9 is 10. Yes. And then so on up to last is going to be what? Coefficient of x to the power 10 in 3 plus x to the power 10 only. So this thing we have, that means now I can now write down coefficient of x to the power 10 in. So which means we have here 20c0 into 3 plus x to the power 20. And then again minus of, so we have here 20c1 into 3 plus x to the power 19. Then plus 20c2 into, of course, 3 plus x to the power 18 would be there. And this journey would go on up to last, which is 20c0 into 3 plus x to the power 10. And now if you look at this, then this turns out to be someone's binomial expansion. 20c 10. Okay, this is 10, not 0. So this is going only up to 10. So 20c10 and then 3 plus x to the power 10. So this looks like binomial expansion, but some of the terms are missing. So that means after 10 onwards, we need to write down. So after 10 onwards, if I write down here, like say this, say minus 20c11 into 3 plus x to the power 9. Then plus 20c12 into 3 plus x to the power 8. And so on. All these things I'll add up to 20c20 into 3 plus x to the power 0. That's what we have. So we'll be adding it here, and then again, same thing, we'll be subtracting. So that means I'll be writing the addition and subtraction here because we have to use this thing. So this is minus, yes. So minus, and then now we have to add and subtract. So I'm writing this quantity again. So plus 20c11 into 3 plus x power 9. Then minus 20c12 into 3 plus x to the power 8. And so on up to minus 20c20 into 3 plus x to the power 0. We just have added and subtract because this looks like a binomial expansion of up to here. We can now write down coefficient of x to the power 10. This coefficient of x to the power 10 in. So now if I look at this bracket, then this looks like expansion of 3 plus x minus 1. So 3 plus x minus 1 to the power 20. And here in this expansion, this part will go right there, this, and then minus plus 20c11. So plus 20c11 into 3 plus x to the power 9. And so on up to 20c20, 3 plus x power 0. So now if I want the coefficient of x power 10, of course, I won't be getting all these terms. So this term just goes away, and simply I'm left with coefficient of x power 10 in this. So which is equal to coefficient of x to the power 10 in 2 plus x to the power 20. So which is simply 20c 10 into 2 to the power 20 minus 10, which is 10. That's what we get. So n c r to p power r. If I compare with the given thing, it's n c r p power r. So we get n is equal to 20, p is equal to 2, and r is equal to 10. So adding all of these will give me 20 plus 10, 30 plus 2, 32. So the answer would be 32. Let's go for the next one. Okay, so here is the next one. We want to find out this limit, and limit extends to 0. Sigma r is equal to 0 to n minus 1 to the power r into ncr. Then we have one more sigma here, which is k is equal to 0 to n minus r c k times 2x to the power k. This gets closed, and then we have here x square minus x to the power r. And this 1 over x, we will see it later. We have to see it now. It's 1 over x, because that's the limit. So now if I go and simply find out this thing first. So since sigma k is equal to 0 to n minus r, we have n minus r c k into 2x to the power k, which means 1 is missing here. So 1 n minus r minus k we could write. Now this is nothing but 1 plus 2x to the power n minus r. That's what we have. Because this is the expansion of 1 plus 2x power n minus r. Now this entire thing I can plug in here. So this would give me limit x tends to 0, and then sigma r is equal to 0 to n minus 1 to the power r n c r into 1 plus 2x to the power n minus r into x square minus x to the power r to the whole power 1 over x. Now looking at this thing, this again reminds me of NCR, x to the power n minus r, y power r, minus 1 power r. So we can now write down this is nothing but limit x tends to 0, and this is nothing but 1 plus 2x a minus x square minus x to the whole power 1 over x. Now this thing, where is n gone? Okay, so this expansion n is there. So that's like this, basically, power n. Because it's like a minus b to the whole power n. So that means now I'll be having limit x tends to 0. So limit x tends to 0. 1 plus 2x minus x square plus x, which means 1 minus x square plus 3x. So 1 minus x square plus 3x to the power n over x. Yeah. And now if I look at the limit x tends to infinity, then this looks like 1 to the power infinity form. So for 1 to the power infinity form, this guy tends to 0. That means we could write e to the power limit x tends to 0, x square plus 3x over, this would go to what here, say n, and then here x. Now we can simplify this further. So limit x tends to 0. This will be x plus 3 into n, which gives me e to the power 3n. So now for e to the power 3n, we need f of 1 over 3, and that to GIF. So f of 1 over 3 would be equal to simply e, and GIF of e is nothing but 2.71832 GIF if I take, and this turns out to be 2. So the final answer is going to be 2. Moving to the next one. So we have the other one, and it's given that ax plus by plus c is equal to 0, be any normal to this ellipse. Then we want the maximum distance of this normal from the center of this ellipse. Okay, no problem. So suppose this is some random ellipse. Okay. And I take a point here P, which is going to be a cos theta, comma b sin theta. So, since we do not know what is this a and b, we'll take a cos theta, comma b sin theta. Now we want the equation of the normal. So equation of the normal. So equation of the normal at p is going to be ax by cos theta minus by by sine theta is equal to a square minus b square. That's the equation of a normal. And now what do we want? At point P. So now if we go ahead, okay, so this is my normal right here. Now this is the center of this ellipse. So we want the maximum distance. So let's find the distance of this normal. So say d is equal to, from the center we are asking, that means this is going to be um, simply a square minus b square over square root of a square secant square theta plus b square cosec square theta. A square plus b square, this is going to be my distance of this normal from the center. And we want this distance to be what? Maximum. So if this is maximum, then I need to find out the minimum value for this. That's already a constant, a square minus b square. So we want this quantity to be maximum. So for d max, okay, denominator should be minimum. So denominator should be minimum. So if I want denominator should be minimum, so I'll consider this as a function. Say my f of theta is equal to a square secant square theta plus b square cosec square theta. Oh, we want to minimize this, so of course we can go ahead and write down f of theta is equal to a secant square theta plus b cosecant square theta. Now, a secant square theta could be written as a into 1 plus tan square theta. Okay, this is a square basically. Square and b square. So this is a square and then plus b square into cosec square can be written as 1 plus cot square theta. Now I can write down a square plus b square plus a square tan square theta plus b square cot square theta. Now here I know that this quantity is going to be greater than or equal to 2. So by AMGM inequality. So by AMGM inequality, we could write down this thing is greater than or equal to 2, which means this f of theta is greater than or equal to a square, 2ab, by the way, because if I apply AMGM, so a square tan square plus b square cot square. This over 2 is going to be greater than or equal to root of a square into b square, tan and cot get cancelled. So 2ab, so a square plus b square plus 2ab, which means this is greater than or equal to a plus b the whole square. So that means my minimum of f is going to be a plus b square. So here we have considered square root. So that means d is greater than or equal to modulus of a minus, oh sorry, less than or equal to, because we're in the max. So d is less than or equal to a minus b over into a plus b, and here we again get a plus b, but that's squared, so a plus b, and this gets cancelled. So that means mod of a minus b I get. So a minus b means this is my a and this is b. So d is equal to modulus of sigma cos power 4 theta, and theta runs from 1 degree and goes up to 179 degree. This minus sigma theta is equal to again 1 degree to 179 degree. This is nothing but sine to the power 4 theta. Now this can be clubbed into 1 because the dome limits are same exactly. So d is going to be modulus of sigma theta is equal to 1 degree to 179 degree. We have cos to the power 4 theta minus sine to the power 4 theta. This could be further written as sigma theta is equal to 1 degree to 179 degree. Cos power 4 minus sine square is nothing but cos square minus sine square into cos square plus sine square, but that is 1. So it's nothing but simply sigma theta is equal to 1 to 179 degree. This is cos 2 theta. So this is simply cos of 2 plus cos of 4 plus cos of 6 degree, of course, and so on up to cos of 179 into 2. So this is going to be 2 times 179 degree. Now these are in AP. So cos 2 plus cos 4 plus cos 6 and so on. So we can apply the formula for the AP here. That is cos of A plus cos of A plus D plus cos of A plus 2D and so on up to cos of A plus n minus 1 D is equal to sine of n d over 2 over sine of d over 2 into cosine of 2a plus n minus 1 into d over 2. So that means this is going to be total up to 179. So this will turn out to be simply cos of sine and sine. Okay, that means this entire thing turns out to be cos pi here to sine pi by 2 and d by 2. So 179 into d by 2. Then again sine of this is degree of n d by 2, and d is going to be 2 actually. So sine 179 and sine 1 both get cancelled. So cos pi, this turns out to be simply minus 1 in the modulus. So that means this entire thing turns out to be 1. So the answer here is going to be 1. Thank you so much for watching. Happy learning.